Okay, in Chapter 3, what we're going to be discussing are the different objects that we use for the aggregated data. In addition to that, we're going to be discussing some of these specific tables within an object. What is an object is usually the first question. And an object is any grouping of tables that have a similar behavior. So the particular objects that we're going to be discussing in this video is the area type object that includes the area and also the area text. And then we'll also go look at the legend table and all of its child tables. The map unit object that includes the map unit table and all of its objects. And the data map unit object that includes the data map unit table and all of its objects, including the component and the horizon. So you get a better sense of the terminology in the database world as far as an object and a table. Now we have no representation. You can't visualize these particular objects and their relationships. And so what we've done is we've developed on the NASIS webpage the metadata. And this is the 6.2 metadata. The 6.3 will be out shortly. But we have these structural diagrams, and the structural diagrams basically provide you some sort of representation of how all of these fit together. And so we've got the area type object, it's in black, the legend objects in red, the map unit objects in green, and then the data map unit is in blue. This provides you some sort of idea, concept of a visual representation of this database and the variety of tables. You'll notice anything that's got a black arrow is a direct relationship between that one table and the following table. We have the main tables going straight down the middle, the area type, the area, the legend map unit, the correlation, the data map unit. And the way this works is we've got each one of these are independent upon itself. Object is independent. So we've got all of the soil survey areas within the soil survey area type, and they consist of basically independent upon themselves. But you can link those to a legend, and that's what that magenta colored arrow is for. That magenta colored says that we're crossing an object and we're going to link this area to a legend. And then the legend has a direct relationship to the legend map unit. However, the map units have a direct relationship to the legend map unit table. In other words, we have to link a map unit to a legend map unit. And in doing so, you'll notice that the magenta arrow is now pointing up. The map unit has a correlation table, direct relationship, child table. However, we can link a data map unit to a map unit object using the correlation table. The legend map unit table and the correlation table are both linking tables. They link another object to that particular object. So we link a map unit to a legend using the legend map unit table, and we link a data map unit to a map unit using the correlation table. I hope it gives you a better sense of the reason why we use these diagrams to represent this database. You're not going to see it in the database world. Okay, this is the web page, and you should be familiar with this web page. If you're not, you need to understand that we have the diagrams for each one of the sets of objects, and you'll notice the other ones that we'll discuss in future videos, the sites, PEDON's projects, and the NASA site. We also have the tables and columns report. There's a series of reports that we go through. And the particular report that we're going to look at here is the tables and columns report. This is another way of being able to provide you information. And in this report, the only two things I want to focus on are the physical name. This is the physical name of the particular column that's in the database, and then the column label. And the label is what you see whenever you're looking at the user interface column, or if you're printing these out into a report. This is, even though area symbol is the physical database name in the database, area symbol with uppercase A space and the uppercase S is what you'll find on the report whenever you print out that particular column. So these are the two tools that we use to be able to identify the visual representation and understand the relationships between the tables and the columns. So I hope this gives you a better handle on where to go and what these tools are used for. Now then, getting back into NASIS. Pardon me. You'll notice we can open up the area type table. We can open up the legend table, the map unit table, and the data map unit table. There is no information, no data in my local database right now for the legend, the map unit, and the data map unit. You can open up the trees associated with each one of these objects and look at the particular tables. You can open these tables up independent of one another. I could open up the map unit history, although it does me no good. I will state that you'll be using these by opening up later down the road in future videos. One thing I want to point out to you in NASIS 6.3 is we have included a legend map unit history table, and we'll be discussing more of this here in a little bit when I load data up. We have not discussed the refresh of the local database, but one thing that I need to make you aware of is everything that's in this Explorer panel is residing in your local database, so that when you do a refresh, you load all of this information up. Now, I want to show you how you can load up a particular set of areas, and I'm going to run this against the local database, because since the local database contains all of the areas in NASIS, and so you do not need to run a query against the national database in order to retrieve the areas. They already reside, and whenever you refresh your local database, any new areas that are created come down. And an area is nothing but a spatial entity, a spatial representation of how we manage data. So I'm going to run this one, and this is area by area type, name, and area name by NASIS site. And so I'm going to say, give me all the area types. And I want every single area type. I want all of their names, so that's another asterisk. And I want everything that's in the NSSC Pangea. I'm going to use wildcards to pull up just star pan star. And I'm going to run this. There are 19 area types. And we're going to only discuss the area types in the area before the end of this video. You'll notice that we have the non-MLRA soil survey area, and I can click on this, and I can open up this table. And this table now contains all of the soil survey areas. You'll notice there are 3,589 soil survey areas identified in the country. And as I scroll down through this list, you'll notice that some of these are marked as obsolete, and they've been replaced with other soil survey areas. So you can see that that's how we manage these soil survey areas. And then soil survey area boundaries change in the western part. For the most part, you'll notice that in the east of the Rockies, almost all of our soil survey areas are contiguous along the county boundaries. They are not counties, they are soil survey areas. However, it still provides you an idea of how we manage these. And then they use the FIPS codes, the state abbreviation, plus the county FIPS codes in the dominantly in the eastern single county particular survey areas. But when we get into multi-county or pieces of counties, then we start using the 600 and the 700 series. And here in Kentucky is a good example of this. So this gives you a handle on those non-MLRA soil survey areas. This is also where we include the MLRAs. And once again, you can see that we've got obsolete MLRAs. We've got a lot of work to do on MLRAs, and that's what you'll be testing throughout your career. So we've also got the county or parishes, and this are the actual counties and the actual FIPS codes for every one of the counties within the United States. So you can load up this data. It's in your local database. You can take a look at it, and you can become more familiar with the areas. In the next video, we'll discuss more about legends, map units, and data map units.